Hi, my name's David Mead. I'm from the Australian Institute of Marine Science. It's my really great pleasure today to give you an update on what's been occurring in the Reef Restoration Adaptation Program since the first Reef Futures conference. RRAP is a pretty ambitious program. We're seeking to deliver a new suite of interventions that helps protect, adapt and restore the Great Barrier Reef. Great Barrier Reef is a very large ecosystem. It's complex. And resilience in itself is a complex thing. And so it's more than just delivering new interventions. It's also assessing that they're going to be safe, socially and culturally acceptable. The program itself is funded by a partnership between the Australian Government's Reef Trust and the Great Barrier Reef Foundation, along with investment from R&D providers and a range of third parties. And right now, just at the outset of this talk, I just wanted to say that reducing global emissions is the most important way to minimise future impact on reefs. And this program is not an excuse to act on climate change. It's simply a recognition that we feel that both are going to be required. The program itself is a little unique in that in 2017, we kicked off a concept feasibility study that then rolled into a design study. And so this program is a designed R&D program. That was in reflection that we knew that an intervention that's going to be deployed at scale is the sum of lots of things. It's not just an idea. It's a consortium, it's integrated, it's multidimensional, public good, and it ranges from fundamental science to quite operational outcomes that we're seeking to deliver. We have a program structure that comprises a range of cross-cutting sub-programs, and then the actual core intervention development programs there in the middle, and an engineering supporting function at the end. And look, there's a lot more details on our website. The link is there, and I do encourage you to go and have a look and learn a little bit more about the program. So 18 months in, we're about 250 researchers. We've undertaken 35 plus expeditions, 500 odd field days. There's lots of projects that have needed contracting. We're planning and tracking a lot of deliverables and managing a lot of cross-program dependencies. It truly is a matrix style arrangement, and it is absolutely a team effort. So I'm here presenting today on behalf of that team. I'm an engineer, not 5 brands of scientists. And apparently I occasionally do use the wrong words, so bear with me. So we know that temperatures are increasing, that we do need to, one of the key things that we're trying to achieve is to increase the rate of adaptation. And so there's a large body of work going on that's looking to see whether or not we can identify corals that already have the phenotype that we're after, the thermal tolerance without the trade-offs, along with, other than we're not doing any genetic engineering, there's a lot of work on all the other approaches around assisted evolution. And so the teams have been out phenotyping thousands of corals, assessing them genetically to see whether or not we can identify genetic markers, and a whole range of crossbreeding lab and field trials, both with the coral host and the symbiont. And if I was to make one observation, the scientists hate when I do this, but that's okay. From what I'm seeing, it's probably less trade-offs than perhaps thought. So we are finding corals that perform well in high temperature events, but also well the rest of the year round. And overall, we're also seeing quite positive outcomes in increasing the thermal range of corals. Supporting that is an aquaculture program. What I'm going to show you here is just some recent photos of the sexual reproduction process that they're developing. So they've now got operational what they call an autospawner. So step 1 here, where they're collecting 2 million larvae per autospawner, and this is automated using their nephelometers. Those are then moved into million larvae culture tanks. And right now in this particular spawning season, they're testing sort of a continuous settlement system. And you can see in this photo here. And in fact, the sediment sheets that they settle on, in slide 4 here, look like a chocolate block on the back, so you can snap them into little pieces. Those little pieces with the settled corals on them are attached to devices and distributed from the surface. So then other parts of this team have been testing different designs in the field to look at retention on the reef, and also the survival of the young corals on those devices. And they're getting really good results, and right now they're just starting to bring in some new, more advanced materials and test antifoulant and probiotics to increase survival rates. Cryopreservation is is a key method that we're exploring more than just biobanking. We're seeing whether or not we can develop higher throughput methods that would allow it to become part of both the research but also future production processes. When you're running sexual reproduction processes in particular and you get one spawning, or a few spawnings a year, if you can use this as a method to buffer, there's really significant productivity gains. The larval slicks teams, they've continued their work in developing the ponds and the systems to collect and disperse larvae. So this is a method where you collect wild larvae and move it to a location that's recruitment limited. But it's extending well beyond that now. They're starting to look at how do you track success more directly, and a lot of work on which larval slicks do you collect. Can you be selective about that, and using clever methods, identify slicks that are coming from areas of reefs that might be more thermally tolerant, and then exactly where do you put them to get best bang for your buck. This is a method that's been a little longer in its development now, and so it's also, we're starting to shift it out into stakeholders and communities. So there's a separate program running that's funded by the Great Barrier Reef Foundation. This is from about 2 weeks ago, where they've taken the method and some of the kits, some standard operating practices, and handed it over to some stakeholder groups. So this is a traditional owner group here, and allowed them to have a crack at doing it. It's really high successful, and we see a big future for this as a method to roll out this particular intervention. We're looking at rubble stabilization. Rubble is a natural part of any reef system. But of course, if you get too much of it, then it becomes a problem because you've got recruitment issues. And so the initial part of this program is mapping the GBR and looking and identifying, creating tools to identify where rubble actually is a problem. But also we're looking at the methods themselves. So we're looking at particular methods that we think will scale out a bit further than the kind of mechanical systems that are available now, which are quite effective, but very expensive at large scale. So there's quite a bit of work studying the process of natural binding and what's required to see whether or not we can also then create methods that would, I guess, speed up that biochemical binding process. Pooling and shading program is kind of split into two parts. One team is looking at cloud brightening, which is a method that slowly cools the seawater and only works at very large scales, and then fogging, which is more about light intensity reduction. These are some pictures from last season. This team is out there right now, straight out from Townsville where I'm located, and they've been developing kind of new variants of the technology. So they're out doing some tests of that. And the program is sort of shifting also into doing a lot more atmospheric modeling and testing in that area. Traditional owners are incredibly important in the Australian context. They've got thousands of years of sea country knowledge. They are the sea country custodians. And we're seeking to merge Western and traditional owner science. And so we have a program of partnerships that ranges from bronze to platinum. Bronze is where it's something that we're doing, and we'll just seek their permission to do it. Platinum is a project that the traditional owners are seeking to do. It's their idea, and we might just provide them some assistance and everything in between. So that program has been ramping up. But along with that, the teams have been establishing engagement groups, regulatory reference panels, a whole range of mechanisms to bring stakeholders and regulators along on this journey with us. Gaining social license and permits is critical, and understanding people's perceptions of risk and providing them with the information so they can make informed decisions is a key part of what we need to do. As I said right at the start, we have an engineering team that's supporting all of this. There are engineers embedded in many of the intervention subprograms, but it's quite a specialist area. And so this team is helping each of those groups really develop the concepts that they want to deliver at different scales, and then they're building models that can model the use of those and understand exactly what infrastructure is required, what the costs will be, and importantly, what skill sets will be required. Is this something that can be done by volunteers, or does this need a large company and heavy engineering type skills? So they've been focusing on this year on going through each of those. And as we move forward, they'll focus a bit more on trying to start to think about how we actually establish some of those those industry capabilities. With something the size of the Great Barrier Reef, it's clear that we're not going to go out and intervene and it's all done in one cycle. In general, what we're doing is seeding an outcome that could take 2, 3, 4 coral life cycle generations for you to see an impact. And of course, that creates a big delay. So you can't run an adaptive process because the benefits occur way down the track, but so do the risks. And so modeling is a big part of what we need to do so that we can have an estimate of risks and benefits. And so we've established quite a large team that are doing this and lots of different models that integrate in together. And they're running a process of an annual cycle of doing a counterfactual. So what do we think the reef is going to do in the different climate scenarios, and modeling the interventions in it. As the models improve, the uncertainty will reduce through time. The panel on the right here is some unpublished and very recent information that I grabbed off the team, just to illustrate, I guess, what we're doing. So the bottom part of it is the counterfactual going forward without any interventions, kind of shows what we saw in the concept feasibility, that we expect to see a gradual decline. The top panel is just starting to demonstrate how we convert that into things that are meaningful, so reef condition and values. Underpinning that, of course, is that you need good information to run good models. And during the concept feasibility assessment, it really highlighted that despite lots of knowledge about coral reefs, there were some quite fundamental gaps in our knowledge base. And so we've established a program, we call it Ecologically Intelligent Reefs. And what they're doing is, over the last 12 months, they've been establishing reference sites up and down the GBR, so across the temperature, thermocline, inshore, offshore, and starting to study a number of really key parameters. So a range of things around natural adaptation processes and rates, and some quite specific coral demographics data that will help guide deployments. And that information then feeds into the models and the interventions themselves. So where is all this heading? We're targeting some sort of small scale deployments from about 24, 25, 2 million corals a year. That's what we think we can do out of our existing infrastructure. Beyond that, we'll have to invest in further infrastructure. Not quite so certain where fogging and rubble stabilization will land. We would hope that by that time frame, we would be in a position to be deploying some of those methods. Clap brightening is a bit of a longer term thing. It can only ever be deployed at large scale. And so the test before you get there is much stronger than something that you can start small and grow. All of that, of course, is subject to permits and social and cultural license. I just wanted to add a few thoughts, I guess, of my own on top of this, just to leave you with. You know, no one idea will ever be the solution. And I really do encourage people to sell your idea on the basis that we're going to need this as well, as opposed to is the best for everyone else, or this will save the reef. RRAP has been successful in getting going because as a consortium, all the researchers came together and we agreed on this principle. If restoring equals replacing, then it's not feasible. So just be smart about how you pitch your ideas. 260,000 square kilometers of corals, trillions of them. We're not going to be replacing them. Do the maths. Will your idea equal the goal? What's the value when you're starting out on something? Just to play it out into the future and see where things will land. And is that where you thought it would? Collaborate and share. I don't need to tell this group that. And finally, yes, we do think that we can do something that is ecologically significant in this space. And so, you know, this is just a screenshot of some of the people working in RRAP. And I'd just like to thank them for all their efforts over the last 12 months. And as a group, you know, I'd like to pass on, have a great conference. And we're really looking forward to things shifting from COVID and being able to do the next one of these face to face. So thank you.